Today we are going to learn how we can integrate code quality tool with AWS Code Commit. So let's get started with today's agenda. So today we'll understand what is the aspect of a good code quality. We'll introduce what SonarQube is, and then we'll do a lab wherein we are going to integrate SonarQube with AWS Code Commit and Code Build services, and we'll set up SonarQube on AWS instance. Okay, so these are some of the aspects of code quality. The code has to be readable. It should be maintainable. It should be easier to scale. Reliable. Yes, it should perform the intended function it is supposed to without crashing, and it has to be secured. Okay. So there are a lot of the one way to ensure that the code which is being merged and which is getting live or deployed is follows all the aspects of code qualities, having a human review your code, right? So you have your senior lead or engineering manager. You can raise a pull request to them and then they can review. But as you know, with human intervention, there is still a possibility of missing certain details. Also, with distributed teams, with multiple projects going on at the same time, it is not feasible that um, it's not feasible that your code would get reviewed in a timely manner. I remember in one of our project, the project was being developed from India side, but the approvers of the pull request used to be on US. So there used to be at least a delay of 24 hours for the review to be done. And in case of any code review, the cycle used to increase, right? Because now it was becoming a bottleneck. Yeah, either people had to come in early or stay late to ensure that the code is reviewed. Yeah. Also, you have to take care of a lot of best practices. Like if you raise a pull request which 100 and 150 lines of a code, for the person who is reviewing also it gets very difficult. So it is advisable that the pull request which you create, it should have small changes, or make sure you do a meeting, and wherein meeting you do the review with the reviewer, right? So these are the things you can follow if you don't want to go for automated approval. But today we are going to learn how integrating your SonarQube in the review process can help you get that review faster. Okay. So yes, there are multiple tools which helps you in doing your static code analysis, and SonarQube is one of them. Yeah. So what is the benefit of SonarQube? It is easy to install. You will see that there are very basic steps to install the SonarQube. It can be integrated with any CI/CD tools. It can be integrated with Jenkins. Today we are going to integrate it with Code Commit. Okay. And what are the things it helps you to do? It helps. So the SonarQube comes with a lot of built-in rules. Okay, for different kind of project, Java, Python, etc. So by default, those rules are applied. They help you check things like, okay, if there are any duplicate code or there are any security vulnerabilities. They also check for things like, okay, if you, the class which you are declaring, what is the nomenclature, what is the length of the class or the method. So I remember that we used to see code smell for things like the number of parameters which you are passing in a method. Okay, so there is limit, like you cannot pass more than 7 parameters in a method. So if it is more than 7, it is raised as a bug in a SonarQube. Yeah. So yes, these are all, and it's a open source tool. Okay. So the project which we are going to do, or lab which we are going to do, this is the architecture of that project. So we'll have a code commit repository, okay, and there would be a CloudWatch event set which would monitor if there is any pull request raised for this particular repository. If yes, then what we have to do, we have to build the project and analyze that project using SonarQube. Okay. And again, as you know, for one system to interact with another system or one AWS service to interact with another AWS services, you need IAM roles or you need some credentials, etc. So, for example, if you want to connect with SonarQube, you need to know the credentials of the SonarQube. So here you can leverage AWS Secret Manager to store your keys, yeah, which is your username and password. Yeah. So these are some of the steps. Let's quickly get into our console and start setting this up. Yeah. Okay. So before we get into this particular demo, I just wanted to let you all know about this workshops.aws. Here you will find a lot of what do you say, projects which you can practice and learn more about. So they have given you the steps, etc. Right? They tell you, okay, what is the level hours. Yeah. So if you want to learn more about AWS, the best way is to practice to a lot of projects. So this is one of the free resources which you can follow. Yeah. Now for today, the project which we are going to do, the details of that project can be found here. As I told you, in interest of time, I've already done the setup, but I'll tell you what are all problems I faced, which you can take care of while setting up this project. Okay. Um, I told you what would be the challenge if we want to get our code reviewed through human, right? Time could be one constraint. You won't get faster feedback. There are possibility of missing certain aspects, right? So it's always advisable if you could automate that process, and code commit comes with some approval template. So I'll give you a walkthrough of what are those template. And apart from this, also you can your Sonar you can help in measuring the code coverage, right? So not only tells you about security vulnerabilities, bugs, etc., but also you can, with the help of SonarQube, you can measure your code coverage. So, for example, you can set up a rule. See here, okay. So you can set up rules like this. Okay, what is your coverage? So if say your unit test coverage is less than 80, okay, then you have to fail the build. Okay, this way you are ensuring that nothing is being merged to the main branch until it has got a good code coverage. Yeah. And then see, you can see a lot of filters. So you can have quality gate, right? It checks based on reliability, security, maintainability, etc. So I had run this particular project, and here one code smell was found. Rest there was zero vulnerabilities and bugs, etc. Right? It also looks for duplication, and you can also measure the code coverage. So to measure the code coverage, etc., we have to do a lot of other settings, right? Because all the reports which gets generated has to be stored somewhere. So you need to set up, what do you say, Postgres, SQL, etc. But today the project which we are going to do is a simple project wherein we are running a, let me tell you what is it that. This is a simple Java project. We are printing hello world is what we are trying to print. Let me show you. Again, this particular project can be found in this blog itself. Okay, so where do you find? You can search under AWS DevOps blog, integrating SonarQube as a pull request approver on AWS command. So if you search with this, you'll find this particular article. Okay, so what are the prerequisites? For this, first of all, you need to set up SonarQube on a EC2 instance. Okay. So one thing to remember is SonarQube requires at least 2 GB of a memory. So for this, T2 micro won't help. So you need to go for T2 small, right? Because this is the mistake I did. I set up SonarQube on T2 micro instance and it was crashing for me. So when I searched, I found out that you need to have at least 2 GB of memory. So T2 small comes with that 2 GB of memory. Yeah. So then what is it that once you've, let me show you. This is my instance. Okay. So once you've make sure you open port 9000, because your Sonar Cube, it listens on the port 9000. So that's additional thing you have to do apart from opening SSH, etc., which is your port 22. Yeah. So I created this instance. After this, what I did using instance connect, I went here, connected to this shell, and whatever steps were mentioned, right? Okay, I installed Java. After installing Java, I did the installation of Sonar Cube. I installed a.o only, right? Okay, so once you installed, I hope you remember how do you install wget, and you paste the address. Okay, then once you've installed, you have to unzip it. Okay, after unzipping it, you'll see that okay, Sonar Cube is present here, and then you have to start the server. Okay, so let me show you where is my, yeah. Okay, so here you can see your Sonar Cube. Yeah, and then there are like other stuff here as well. So go pi Sonar dot properties. Okay, so this is properties file. As I was telling you that if you want to store the report, etc., you need to have some database. So this has detail of those Postgres. But for that, first you have to install Postgres. But right now it's not required. Okay. Uh, so this is a important member if you're setting up some complex stuff, etc. Okay. Yeah. So once your Sonar Cube is started, you can check the status whether it is starting or not. Make sure, yes, one more thing. First thing to remember is you have to have T2 dot small, okay? Because this comes with 2 GB of a memory. That's the first thing. Second, connect to your this instance using this connect. Follow the steps which is given here, okay? And then once all this thing is done, make sure you restart your system, right? So once you restart, uh, start the server, and then what you have to do, how would you access the Sonar Cube server? This is the way. HTTP instance address is your public IP address, and then the port. Ensure your port 9000 is open. Let me show you. Go to security. Yeah, so if you see I've opened port 9000. So this you have to open. Yeah, so T2 small is the first thing you have to take care of. Your instance type has to be T2 small. You have to open port 9000. Once you've done the installation for the Sonar Cube, restart your instance, because I had to restart. It was not coming up for me, though it takes some time. But after trying multiple times, I was not able to see this particular console. So once I restarted, my EC2 instance. How do you restart? I hope you remember. You click here and then you can reboot. Okay. So after that, I went ahead, I started the server and did this on the browser HTTP IP address 9000, and I could see login option. There was this option to login. What is the default username and password? It is admin. So you have to give admin, and you will be able to see something like this. This is your default. I go here, sorry, security user. This is your default user. Okay. And for integrating with, what do you say, with code commit, you can create a new user. And the user which I created was SonarCube. The name was SonarCube, and password was also SonarCube. Okay. That's the first step. What you have to do is you have to launch T2.small and then perform these steps. So this is like you install Java, then you install Sonar Cube. Once you install Sonar Cube, restart your system, and then start the service, start the server. And after a few minutes, if you go to this particular location, you'll be seeing something like this. Okay, so login, and once you log in with default username and password, you'll see all these all these are C predefined rules for different project or language. Okay, for Java, C Sharp, Python. Yeah. So even if you don't set any custom rule, whenever you'll build your project, okay, so it would be tested on these particular rules. Okay. Now next, what you have to do, you have to create a user, right? So this is the SonarQube setup part. Next comes, as I told you, we are going to integrate SonarQube with our code commit. That moment there is a pull request, okay? What would happen is AWS CloudWatch event would be monitoring that, oh, there is a pull request. Okay. So once it sees a pull request, the build would be triggered and the project would be built over SonarQube. Okay. So the project which is built, it would be scanned uh, with respect to the rules, etc., which you have set on SonarQube. If it's satisfied, your build would be passed. Okay. In this case, your PR would be approved, else your PR would not be approved. Okay. Yeah, so these are some of the resources which you have to create, which is like, okay, you need to have a code commit repository, you need to have code build, you need to have a CloudWatch event rule, then IAM role, okay? And then you need to have secret manager where you're going to store SonarQube credential. So one way is you create it manually, but through this project, you are going to learn about another important AWS service, which is your cloud formation. Okay, so what you need to do is go to this particular link. Okay, it takes you here. Okay, and there's this template .yaml, yeah, which is your cloud formation template. So all the resources which we have to install, which is your code commit, code build, CloudWatch event, IAM role, etc., would be created using this template. Download this template. Okay, once you download, you have to go to cloud formation. Okay, let me take you to cloud formation. Okay. There would be this option, create a stack. Okay. Click on this, create stack. Yeah. Then upload the template. The template would be this one, which you would have downloaded. Okay. After that, as you go, it would ask you for the SonarQube credentials, etc. So, which is the one which you have set up here, whose name was SonarQube, username was SonarQube, and password was. So, it's very important that you remember those details. Yeah. This is one thing. Okay. So, once this tab creation is done, let me show you the one which I had created. Okay. So you can see what all resources were created. Yeah. So this is like, okay, we are using AWS Secret Manager to store the secret. Here our secret is the username and password. Yeah. And if you go here, let me show the build.spec.yaml. I hope you guys remember these files, right? We have used appsec.yaml or buildspec.yaml previously also. So they have the steps which helps you to build the project, what you need to do before build and post build, right? So if you see pre-build, you are specifying, okay, first you specify the SonarQube URL. Okay, so what is that URL? As I told you, HTTP, then the public IP address and the port number. Yeah, and the repository name. This is same. Okay, so here all these repositories, etc., are created through your cloud formation template. So this is the repository which gets created: pull request, approver, block, dem. Okay, so this is the default repository which gets created. This has same code which you see here. It's same. Okay, yeah. Right now, SonarQube and password. Either you can just hard code it, which is not a good practice, or you can store it in secret manager and then fetch it from there. Okay. And then since it's a Java project, Maven is what we are using to build that project. So you do Maven install. And after post build, it would look for, okay, whether what did you see on your SonarQube. Okay. Yeah. So where were we? Yeah, you have to go to the cloud formation console, upload this template.yaml file. This is really important. The role which gets created right here. Let me show you. So role. Okay, this role. This is really important. Okay, I'll tell you where this would be used, because ultimately, see, your code build is communicating with code commit repository. So you need to have some role, right, to access these services, right? Yeah. So just save this particular ID. Now we would go to the code commit. Okay. Let me quickly revise for you all, because we've discussed so many things. First and foremost, what we are trying to do is, instead of manually approving your PR, which is pull request, I hope you know what is pull request. Okay, so once you raise a you made some changes, you created a branch, you made some changes. Now you want to merge those changes to a master branch. So for that, you raise a pull request. Okay. Now, before merging anything to the master, because that's the code which is actually gets deployed to production, you want to get that code approved. Yeah. So one way is manually approving. But with manual approval, there is a lot of challenge. One challenge, which I told you, if the team is not co-located, so there would be some delay. Yeah. So another way is, what you can do is, you can say that you can set up a rule that, okay, whenever there is a PR is raised, so you'll have a CloudWatch event which would be monitoring your AWS code commit, and moment it would see that there is a PR raised, what it would do, it would build that code, okay, and do a static code analysis using tools like SonarQube, okay. And SonarQube comes with a lot of predefined rules. It helps you to find those code smells, duplicate code, longer classes, security vulnerabilities, etc. If you want, you can define your. Also, it helps you to measure the code coverage. Yeah. So, whatever you've set, that all these are the criteria which should be followed by your any PR which is raised. So if your PR is following all these criteria, all these rule, so now your PR gets auto approved. Once it is auto approved, you can go ahead and merge it, right? So code commit has this option wherein you can create the template. So one way is, for every repository you create those rules, or you can have a template. Okay. So once you create that template, whatever rule you've set, it would be applied for all the repositories which you have created. So how do you create those? See, this is your repository. Okay. How is this repository created? I told you through that cloud formation template. And here you've created your rule. Yeah. So requires SonarQube approval. This is the rule I've created. Yeah. So this number of approval needed, one. And here this particular step is for providing that role which your code build is going to assume to access your code commit or SonarQube, etc. Okay. And on which repository? Here, if you want to specify a repository, you can do it, or you can leave as it is. Yeah. So yeah, this is what we did. We've created template, and with this template, we've associated our pull request. Sorry, code repository. Now that's one thing that's done. Okay, so we've installed SonarQube. Okay, on our EC2 instance. The instance type was t2.small. We saw the URL. We created a user. Okay, this has the steps to create user. Then we had to create some resources, which was created through the CloudFormation template. Again, from where you found the CloudFormation template, this has the link of that GitHub repository. You need to download template.yaml. Okay, once you've downloaded template.yaml, you go ahead and create a approval rule template, and you specify how many approvals are required. Okay. And now what you do, you go to your code commit repository and open the build.spec.yaml file and specify all these details, right? So what is it that you need to update? The host URL. Okay. So all this you're doing through a branch, you'll create a branch. Now, how do you merge your branch into a master? You create a pull request. So once you create a pull request, this template comes into picture. Okay. So let me show you when I had raised a pull request, what all you'll see. Okay, and we'll create one, right? This is my code. This is the pull request which I had created. Okay, this was the pull request. What do you see? The approval status is approved. This was not approved manually, but through this particular rule. Yeah, and then if you go to code build project, here you see this is succeeded. Okay, so whatever changes I did for that, the code build was run, and the code build, what it did, it analyzed this particular code using SonarQube, and in SonarQube we didn't see a lot of vulnerabilities, etc. Yeah, so you see overall the quality gate is passed. Okay, we can go ahead and merge the changes. Yeah, so let me show you all of this again. So this was all about the setup, etc. So let's go ahead and create a new branch. Okay, so I'll go here, repository. You'll see when PR is raised, what all happens. Okay, and you can see all the details in the CloudWatch log as well, right? So if you go to log group, so you can see all these details here, what all is happening, right? So when you are building the project, remember build.spec.yaml tells you what needs to be done before build, after build. So in those steps only we've said that this code needs to be analyzed using SonarQube, and hence we had provided those detail, the URL of SonarQube, the username, password using which we have to connect to the SonarQube. Okay, so you can see all these details here. Yeah, and this is the ARN, this step. Remember, we told that, okay, for the code build to access your code commit or a SonarQube, it needs to have some role associated with it. So this is that role. So this particular page is very self-explanatory. You just need to follow, and you'll be able to take care of this project. Okay, and it's good if you face difficulties, because that is when you learn, right? If you see, let me show you. My fourth pull request got successful. So for first three, I faced some or other issues, and I did the troubleshooting, and I was able to fix those issues. Okay. Yeah, so we'll go ahead and create a branch. Create branch. Branch. I'm creating this branch from the main branch. Okay, so yes, demo branch. Okay, so let's make some edit. Let's make edit to the main file itself. Okay. And remember to once you're done with this particular exercise, remember to delete all the resources. Here we are not using the free tier instance, right? So it's t2.small. It would come with some cost. So ensure that you delete. Okay, hello world from Talent500. Okay. Let's say Talent500. Okay. And this is the test photo approval. Matrices. See what would happen. There is an event. What is the event? We are going to see a pull request. Okay. When you'll commit and you'll create a branch, nothing would happen. But moment you'll raise a PR, this is how you would create pull request. And here you're specifying that this is my source branch. This needs to be merged to destination. Once you click on compare, you can see what was the change. But okay, demo PR. Okay. Here also you can see what changes I did. Okay, so now remember this architecture. What has happened? There is a pull request created. So AWS CloudWatch would listen to this particular event and then it would invoke code build. Okay. Now code would build what code build would do. It would pull the code or a branch for which this PR is raised, and it is going to scan this code using SonarQube. Okay. And where we have specified all these things for code build, the important file is buildspec.yaml, where we have specified all these steps. And what is the role of AWS Secret Manager? It stores your credentials for SonarQube. Okay. So again, how is all these things created in this particular example? Using the CloudFormation template, which is given here. Okay, this has all these details. Okay, what needs to be done, pre-build, post. Sorry, this is the CloudFormation template, which tells you about these resources. And then buildspec.yaml has all those other steps about pre and post build, etc. Okay. See, this is analyzing the solar cube. You see, you analyze if there is no vulnerabilities, nothing. Yeah, it would mark your build as success. And if build is success, you'll see the status for PR as approved. Okay, so let's go ahead and see. See, there is 0 of 1 rule satisfied. So what is one rule? This has to be scanned using solar cube. Okay, and if we go to code build, you'll see this has started. Okay, once this is success, you will see that your pull request is approved. So it would take some time. Okay, I think it is going to take some 8 to 10 minutes. The last one took those much of time. So let me tell you what would happen, right? So once you see merge, you have to do it manually. But what would happen if this is success? The the PR which has been raised. Once it is the scanning is done using SonarCube and it meets whatever rules and policies etc. you've set up. Once it sees okay, it is a success. What would happen is the which you've approved. Okay. See, the status is open. Open means you've not merged it. But what is the approval status? The previous one which I had done was approved. For this one, it is still waiting because once it is built, you'll run that build on those SonarCube rules, etc. Okay. So it would take some time. Yeah. But yeah, you can go more. You can click on the PR and go to the approvals and you can see, okay, how was this approved? What was the approval template which was applied? This is the template. Okay. The user which approved it, in this case, it's a IAM rule. Okay. And what else you can see? In the activity tab, you can look at the solar cube analysis which was done, right? So it would take you somewhere here and you will see the detailed result. So overall quality gate is passed. Okay. There are other things as well, like people integrate your Sonar Cube with bug reporting like Jira, etc., project management tool. So for every vulnerabilities you see, you can raise a Jira ticket, work on it once it's passed. So you can do all those kind of integration. Yeah. So I'll wait for 1 more minute to see if the build is successful. Yeah, it's still in progress. It would take some time, but let me show you one more thing. Like you can see the logs, etc. Okay, you can go here and you can see all your build logs. So in case of a failure, you can find detail what caused the failure, or you click on view entire log and it would take you to AWS CloudWatch. Look into that log group. Yeah, and you see, yeah, still the execution is going on. Okay. So I think that's it for this particular project. Let me quickly recap what all we did. Okay. Um, Feel free to what do you say? Uh, Share if you face any issue in the comment. Okay, though whatever issue, as I always tell you, everything is out there. There are really good blogs and tutorials, and plus AWS documentation is also very detailed. So whatever issues you will face, you'll be able to find the solution. Yeah. Some of the things which you have to take in mind while working on this project for practice, maybe in real life. So here I was using AWS Linux instance. Maybe you want to do all the setups on Ubuntu. So the command would might change, but the logic remains same. Okay. So let me quickly revise on the aspects of code quality. These are some of the aspects. How you can take care of these aspects, either doing a manual review of the code commit which is done, or have some automated way. One way is having some static code analysis tools like SonarQube, which helps you to measure the code coverage, plus things like code smells. It checks for your code for security vulnerabilities, etc. Right? And then we talked about SonarQube, which is easy to install. It can be integrated with CI/CD tools. Today we did all the integration with Code Commit. In upcoming session, we'll learn more about SonarQube. Today was kind of introductory session. In upcoming session, we'll learn more about SonarQube, and also we'll try to integrate SonarQube with Jenkins. Okay. Yeah, and it already comes with a lot of well-defined rules. Those should be enough, but if you want, you can have your custom rules, etc. And the project which we did consisted of these particular services. Also, you learned about AWS Cloud Formation, which can helps you to set up those infrastructure. Yeah, and since it is written in YAML format, it is very easy to understand. Like if you read that template.yaml file, you'll see what all is happening at each level. Okay. And finally, before I close this session, make sure you delete whatever you've created. So in the article also, if you see at the bottom, it tells you about a very important step that, oh, you go ahead and delete the stack and delete your EC2 instance, etc. Okay. Okay, guys. So see you in next session. Thank you. And yes, don't forget to check out this particular site, workshops.aws. It has got a lot of hands-on tutorial. So you can practice more using these articles, these hands-on tutorials, etc. Okay. So thank you. See you in session 7, where we'll see how we can integrate SonarQube with Jenkins. Okay. Thank you.